So pH, you might have heard this term before, is a measure of how acidic something is. Okay? Now, this is how it is calculated. The pH is simply equal to the negative log and base 10. That's why I didn't write it there because it's implied. It's base 10 of this number. What is this number? This thing right here simply represents the concentration of H plus, the hydrogen ion. Okay, so again, you don't have to know super duper chemistry at this point to do this problem, but I just want us to see where this comes into play, right? So this is a measure of the concentration of H plus. That's all pH does. It just measures this number. We say something is more acidic if it has a higher H plus concentration. More acidic implies a higher concentration H plus. Less acidic would be a lower concentration of H plus. So let's see an example of this. All right, so here are two example problems. So we have some solution where its hydrogen ion concentration is 5.31 times 10 to the negative 9. Oops, you're gonna see this scientific notation a lot because these concentrations are actually very small numbers. 5.31 times 10 to the negative 9th molar. So that's how you say this big M. Molar is just a measure of concentration. Don't worry about that because this is not a chemistry class, it's just simply an algebra class. But that's what you're gonna see. Okay, so the question is, what is the pH? I didn't write that down in the question, but what is the pH? Oops. The pH, oops, and it's applied big H, so little p, big H. Well, this is nothing too crazy. You're just gonna throw this into the formula. So the pH is gonna be equal to negative log base 10 of 5.31 times 10 to the minus 9. Final answer. So remember, you're taking the log of this number and then just sticking a negative sign in front of it. So I will do that, and we will get, let's see, log of 5.31 times 10 to the negative 9 is equal to that. And I get 8.27. Okay. By the way, however many, actually, I believe this should be 5. I believe it would be proper. Okay. 8.275. Hang on to that, because now I want to take a look at the pH of vinegar here. So the pH of vinegar is 2.5, and this is the opposite question now. We have the pH. What is the hydrogen ion concentration? So let's work it out. This would mean that, well, since our formula is pH is equal to negative log base 10 of the hydrogen ion concentration, this is going to say that 2.5 is equal to negative log base 10 of the concentration here. Okay, we're going to have to do a little bit of rearranging here, but this is where our definition of the logarithm comes into play. Okay, so this negative sign gets in the way a little bit, so I'm going to just divide both sides by negative 1. Change this equation to negative 2.5 is equal to this. Okay. Well, remember, the definition of logarithm says that I could just turn this expression from its logarithmic form, or this equation rather, into its exponential form like so. So 10 is our base. 10 is our base. What the logarithm is actually equal to is the exponent, the power. Sorry about that. Negative 2.5. And the final answer is the argument of the logarithm, is the concentration right there. Okay, so we can actually calculate this now, and I'll just do that. So we have 10 raised to the negative 2.5, and that's going to be equal to, now usually you're going to want to actually put this in scientific notation because this number will be relatively small, but I get 3.16 times 10 to the negative 3. Right there. And this units that come out of this are molar, by the way. Don't worry how the units work out at this point in time. All right, check this out. If I'm comparing these two solutions, so I'm going to box them here in purple. solution A and then the vinegar solution. Which one is more acidic? So remember that acidity is measured, more acidic means higher concentration of hydrogen ion. Okay, so which one of these numbers is bigger? Well, the vinegar has a less negative, the exponent is less negative. So this number is actually bigger. This is bigger than the other concentration. This would mean then that vinegar has a higher, let's write that down, has a higher H plus, higher than the original problem, sorry, than the first solution. And therefore, it is more acidic. More acidic. So you're getting a little bit, by the way, you're getting a kind of free mini chemistry lesson right here. Is more acidic. However, how would the pH compare? And this is, I think, what gets people confused when you see it like in the news or whatever. Look at their pHs. Oops. The pH of the first solution is 8.275. The pH of vinegar is 2.5. Now, I know that this is only one example, but to be clear, it is also has a vinegar which has a higher H plus concentration and is more acidic, has actually a lower. So my tablet has a mind of its own sometimes. Has a lower pH, and so actually, pH and acidity, they are negatively associated, or inversely associated. Some might say, negative. Although that might be wrong. Or they are negatively associated, meaning as one goes up, the other one goes down. So a low pH means actually more acidic. Okay. I just thought that, hey, this is one of my favorite applications of logarithms because those of you that know me know that I actually studied chemistry in college, not math. Well, I studied a little bit of math, but my major, my undergrad was actually in chemistry. And so that's why I always like to pull out this lesson. Alrighty? Thanks for watching. I'll see you later.